So as we work with the equations where you have a log on both sides, like example B here, um, the logs do need to match. In other words, they need to have the same base. I don't really think that you're ever going to run into a problem where they don't match, but I did want to say that they should match. When you have, and that's all that should be on that side of the equal sign. You can't have like a +3 on the end of this or anything, or a ×2. Out here in front. You can't have, that 2 out here in front. If you did, you would have to use the product or the, well, I don't remember what that's called, the exponent property, the power property to move it back up here. But the two logs have to be isolated. If the two logs have the same base and they're isolated, then they just simply drop. And you work with what you were taking the log of, and it just becomes a pretty simple Algebra 1 problem. So we'll finish solving this by subtracting 3 from both sides of the equation, and that's going to leave me 4x minus 2 is equal to 6. Add 2 to both sides, and that'll leave me 4x is equal to 8. Divide both sides by 4, and you end up with x equals to 2. Check for extraneous solutions. If you plug 2 in here, right here, for x, you get 14 minus 2, so that would be log base 5 of 12, which is can be evaluated, and then you plug 2 in right here for this x, and 3 times 2 is 6, and 6 plus 6 you get 12 as well. So 2 is the part that works. Now this one, part C right here, at first glance, you may think, oh, this doesn't fit, because we don't have a log on both sides of the equal sign. We have 2 logs on this side, and we have 0 over here. Well, the fact that we have a 0 over here means that while we do have 2 logs on this side, if I just do the inverse operation of this subtraction right here, and I add the natural log of 4x minus 6 to both sides, then those add out, and I end up with the natural log of 10 equaling the natural log of 4x minus 6. And what do I have now? But logs on both sides. The logs drop off, and I end up with a pretty straightforward algebra problem. Add 6 to both sides. 16 is equal to 4x. Divide both sides by 4, and x equals 4. Plug the 4 in right here for this x, and 4 times 4 is 16. 16 minus 6 is 10, and so it is not considered an extraneous solution.